Vampires, werewolves, and other supernatural creatures that could exist in our world are common knowledge. Many people think that Earth isn't the only habitable planet in the universe, and they base their assumptions on various theories and pieces of evidence. Everyone has wondered, are there any other intelligent life forms in the universe besides humans? The James Webb Space Telescope is one of the few space missions that has put as much strain on NASA and the entire space scientific community. After a cost that ended up being 10 times the original budget and multiple delays, including the new cancellation of the program by the Senate, everyone who was involved breathed a half sigh of relief, if there is such a thing as that. The original budget was only the program's initial conception. Even though the JWST was complicated in every way, the crew that was responsible for launching it had only one chance to get it right. This was due to the fact that it would be located in a location 1 million miles distant from Earth at a point known as the Lagrange 2 point, making it impossible to send a repair mission to that location. This is one-of-a-kind orbit because it enables a telescope to maintain a direct line of sight with the Earth while it revolves around the Sun. This enables the enormous sunscreen on the satellite to shield the telescope from the light and heat of the Sun, as well as the heat of the Moon and Earth. Because the JWST telescope is designed to observe the faint infrared signals emitted by very far-away objects, it needs to be shielded from any bright hot sources, including the satellite itself. Infrared light, which can sometimes be experienced as heat, is a primary type of light that is observed by the JWST. It is the job of the sun shield to keep the delicate mirrors and equipment from coming into contact with not just the sun but also the Earth, the Moon, and spaceship bus itself. The significant disparity in temperature that exists between the warm and the cool sides of the telescope can provide some insight into the heat shield. On the warm side, it was almost hot enough to boil water, while on the cold side, it was almost cold enough to freeze nitrogen. It is necessary for the Sun, the Earth, and the Moon to be aligned in the same orientation for the sun shield to provide adequate protection. The temperature at which the telescope will function is approximately 225 degrees below 0 Celsius, which is equivalent to a temperature of minus 370 degrees Fahrenheit. During the first day after launch, the James Webb Space Telescope (JWST) released and deployed the high-gain antenna in order to enable the highest available data communication rates as early as possible. This was done so that the JWST could complete the first and most crucial trajectory correction maneuver using small rocket engines that were already on board the telescope itself. The JWST carried out its second trajectory adjustment maneuver and started its series of key deployments during the first week of operations, starting with the sun shield pallets in the front and back of the ship. The next step was to extend the telescoping tower between the spacecraft bus and telescope to separate them. The tower had to be extended approximately 2 meters for the remainder of the sun shield deployment to continue. Next, the sun shield membranes were unpinned and the telescoping sunshield mid-booms were extended, which pulled the sunshield membranes out. Tensioning the membranes was the final step in the deployment of the sunshield. In the meantime, other components such as radiators were deployed. JWST completed the deployment of the telescope structures in a second week by unfolding and securing the secondary mirror tripod and rotating and securing the 2 primary mirror wings. Near the end of the first month, it performed the final mid-course maneuver to place it in optimal orbit around L2. Additionally, the various scientific instruments were powered on. A service life of the Space Telescope has been extended as a result of the flawlessness of the launch operation. Previously, NASA estimated that the telescope's fuel would last about 10 years, but due to the success of the launch, the mission can now continue for 20 years, allowing for the capture of breathtaking images of the most distant parts of the universe. Prior to capturing the first images, the JWST will undergo months of fine-tuning its individual components. Using the fine guidance sensor, the JWST will aim at a single bright star to demonstrate the observatory's ability to acquire and lock onto targets. It will then primarily collect data using the NIRCam. Due to the fact that the primary mirror segments have not yet been aligned to function as a single mirror, the JWST will obtain up to 18 distorted images of a single target star. NASA will then begin the lengthy process of aligning all the telescope optics, beginning with identifying which primary mirror segment corresponds to which image by moving each segment individually and concluding a few months later with all the segments aligned as one. Cooling down will end, the cryocooler will begin operating at its lowest temperature, and Mary will be able to begin collecting data. After calibration and commissioning are completed, scientists will take turns using the telescope to study the cosmos. You can see why JWST expectations are so high. In an attempt to answer these questions of how and why we are here, it will appear billions of years in the past. In between these objectives, this powerful telescope will search for evidence of life in deep space. Maybe we will find aliens, but who knows? The Hycean planets are one of the places that JWST will investigate in its search for life. In what ways do Hycean planets differ from other planets, and what do astronomers think they might harbor life? Exoplanets, or planets that aren't in our solar system but revolve around our own sun, are essential knowledge for anyone hoping to communicate with Hyceans. Although astronomers believe there may be billions of exoplanets out there, finding them has proven difficult due to the brightness of the stars they orbit. About 4,000 extrasolar planets, exoplanets, have been discovered so far. To determine if life could exist on exoplanets, researchers have studied them. Scientists check if an exoplanet orbits its star within the habitable zone to determine if it is suitable for life. When a planet is just the right distance from its star, liquid water can exist there indefinitely, increasing the likelihood that it could host life as we know it. But now researchers are focusing on a subset of exoplanets known as Hyceans, which are hot, ocean-covered planets with an atmosphere rich in hydrogen and much easier to find and observe than Earth analogs. Although there are no Hycean planets in our solar system, it is theorized that the kind of life that began on early Earth and can still be found in extreme ocean environments could thrive on the larger and hotter Hycean planets. The fact that they have a wider habitable zone than Earth or Earth-like planets means that they may still be able to support life even if they are located beyond the zone in which a planet is required to sustain habitability. Many of the thousands of exoplanets found in the last 30 years are about the same size as Earth or Neptune. Scientists use names like super-Earths and mini-Neptunes to describe these planets, which can be rocky like Earth or ice giants like Neptune, or they can be somewhere in between. Many Neptune are more than 1.5 times the size of our planet. They are still smaller than Neptune, but they are too big to have a rocky interior like Earth. The pressure and temperature beneath their hydrogen-rich atmospheres are probably too high for life to survive. Nico Madhusudan and his colleagues recently did research to show this isn't always the case. Some of these planets might be able to support life depending on their size, mass, and temperature. Their research led to a new way of classifying Hycean planets. These planets can be up to 2.6 times the size of Earth, and their atmospheres can get as hot as 392 degrees Fahrenheit or 200 degrees Celsius. Under their hydrogen-rich atmospheres are oceans that cover the whole planet. These oceans could be home to microbes. Some of these planets may be tidally locked, which means that one side always faces the star they orbit and the other side is always in the dark, just like our moon. In this case, tidally locked planets in Hycean might only be able to support life on one side. There are a lot of known exoplanets, but super-Earths have been studied more than Hycean planets. Maybe the answer to where life might exist outside of our solar system has always been in this range. Scientists look for biosignatures like oxygen, methane, nitrous oxide, and ozone, or biomarkers like methyl chloride and dimethyl sulfide, which are all found on Earth, to see if a planet in the habitable zone has the right ingredients for life. Scientists have been looking for these different molecular signatures in Earth-like planets, which makes sense as a starting point, but Hycean planets offer a better chance of finding several trace biosignatures. One example of Hycean planet is K2, 18b, which has been called a mini-Neptune or a super-Earth. The red dwarf star K2-18b, which is about 124 light-years from Earth, is a star that the exoplanet orbits. It was found in 2015 by the Kepler Space Telescope. K2-18b is about 8.92 times as much matter as Earth. At first, it was said that it might have a rocky core, but in 2019, two separate studies used data from the Kepler Space Telescope, the Hubble Space Telescope, and the now-defunct Spitzer Space Telescope to confirm that it did have a rocky core. Studies show that this planet outside of our solar system is a water world with a lot of water vapor in the air. One of the studies in September 2019 issue of Nature Astronomy says that K2-18b is a once-in-a-lifetime chance to learn more about how planets in the habitable zone are made and how their climates work. K2-18b has been called a mini Neptune and is now called a Hycean planet. Madhusudan said that most Neptunes don't belong in this new group of planets because they are too big or too hot. This is why the Hycean planets are in between super-Earths and mini Neptunes. The JWST has improved scientists' ability to observe distant exoplanets, most likely beginning with the K2-18b, allowing for more in-depth research into Hyceans and their potential status as hosts of life. Comment below with your thoughts on whether or not you believe JWST will discover alien life. How strongly do you believe in the existence of alien intelligence? Do you agree that humans couldn't possibly be the only intelligent life out there? Do you think it's possible they're on the lookout for other forms of life beyond Earth? Tell us in the comment section below. If you like this video and want to see more, click like, subscribe to the channel, and hit the notification bell. We'll let you know when we add new content. That's it for today, and I'll see you in the next video.